What is OFDMA? Is it the part of OFDM? Is it a new technology? Does it cater to the 4 times speed in Wi-Fi 6? Is it the backbone of Wi-Fi 6? Well, as they say, curiosity is the key to knowledge. And if you are someone who has been struggling to get answer to all these queries, then I welcome you to the third episode of Wi-Fi 6 series. My name is Vibhor, and I'm going to discuss today the basics of OFDMA. Yes, OFDMA is the advanced version of OFDM. So let's first understand what is OFDM. OFDM is orthogonal frequency division multiplexing. And this is the technology which has been used in previous Wi-Fi generations to get the higher data rates. When I say advanced version, there is a concept of subcarriers that comes into picture. And based on that concept, OFDMA has been introduced. Now, is it a new technology? Not at all. OFDMA has already been tried and tested in LTE. Is it the backbone of Wi-Fi 6? Of course, this is the backbone. The feature set that OFDMA brings with it improves the speed settings throughputs up to 4 times as compared to the previous technologies. How? We'll see to it. Coming to the basics of OFDMA, as I said, it's orthogonal frequency division multi-access. So when we say multi-access, it is catered to focus on multiple devices at one time. Now, we all know how the Wi-Fi transmission works. It's a half duplex medium, and whether it's an access point or an AP, they have to contend for the network. They have to contend before they have to transmit any data. Same concept works here, and we call it TXOP, called transmitting opportunity. Whenever an AP contends for the network and gets the transmitting opportunity, then it can cater to multiple devices at one time. Well, getting too complex? So let me clear this with an analogy. I'll use the analogy of road concept. Yeah. So let's see. When we talk about OFDM, let's understand it with a road analogy where there's a single lane. There are multiple vehicles, including bicycle, motorbike, car, and maybe a truck. When they have to move on the road, then entire road can be utilized by only one vehicle at a time. So what does it mean by this? Now I have a single lane. If there is a bicycle, there is a motorbike, then there would be some road which is left unutilized, unused. Can I fit any other vehicle in that? Not at all. So this is how OFDM works. Now, when I bring the concept of OFDMA and I stretch this road to a 9-lane highway, what happens? This is where the magic happens. Now, in this 9-lane highway, I can at the same time parallelly run maybe 9 bicycles, maybe 9 motorbikes, maybe 4 cars, or maybe 3 or 4 trucks. So what does this mean? This means that now I'm able to utilize that unused segment which was not being utilized in OFDM. This is how I can cater to multiple devices at one time. So let's do deep dive into this. When I talk about OFDMA, there are few feature sets that OFDMA relies on. So what are those? A very beautiful concept of grouping. Now, I discussed about that OFDM is based on subcarriers, and we divide those subcarriers further to get OFDMA. Now, when you talk about subcarriers, let's take an example. We have 64 subcarriers in OFDM, and if we divide it further, we get 256 subcarriers in OFDMA. Now, there's a beautiful concept of grouping. When we group these subcarriers, we make it an RU called resource unit. Now, these resource units are then utilized to cater to the different segments of traffic. We have 20 megahertz of channel bandwidth. Now, in this 20 megahertz, each comprises of 26 subcarriers and it makes 2 megahertz of bandwidth. So in 20 megahertz of channel bandwidth, if I have a small segments or small lanes of 2 megahertz each, then the maximum that I can cater the client request comes out to be 9. Similarly, if we go with the chart, we have 20 megahertz, we have 40 megahertz, we have 80 megahertz, and we have 160 megahertz. And this is how we see the resource units. Resource units is one part, grouping is one part. Another feature set that comes into picture is uplink and downlink transmission in OFDMA. Also, trigger frames and buffer status reports. So what are these? I'll give a brief about in this video, and then for the deep technical dive, I have to fall back to my second video. When I say uplink and downlink, the best part in OFDMA is AP takes care of all the scheduling, whether it's for downlink or uplink, which was missing till date with the previous technologies, or I should say OFDM. But wait, it's a very important point here. When will OFDMA kick in? If in case we have an access point which is supporting Wi-Fi 6, if we have client which is supporting Wi-Fi 6, then yes, OFDMA will kick in. The concept of contention window. When AP gets an opportunity, then it decides how many clients it has to cater the request to. Now this is where a trigger frame comes into picture to get the data. It also utilizes a buffer status report in order to understand how much traffic a client has, how much traffic it has to send towards the access point. And in this, there's another new concept of padding that comes into picture. Yeah. I know I'm not going to discuss those concepts because then it would be too technical. So this is how, with these feature sets of grouping, resource units, trigger frames, uplink, downlink OFDMA as a concept enhances the speed, allows high efficiency, especially in dense environments. This is why we call it the backbone of Wi-Fi 6. So this was all for the basics of OFDMA. Now for the deep dive, watch my space for the next upcoming video where I will discuss many things. How the packet travels during the uplink transmission, how it travels during the downlink transmission, what are the resource units, or on what basis the resource units are assigned. So there is a plethora of information which is coming your way in my next video on Wi-Fi 6 series. Thank you for your time for watching this video. I hope I would have added some value. Have a great day. Bye-bye.